Today we're going to be doing an application of radicals using figures in geometry and figuring out the area and perimeter of them when the sides are represented by radicals. In question number 1, they give us a triangle. It is a right triangle, so when I'm looking at that, I know that I can consider this to be the base and this to be the height, the two sides that meet at that right angle. So when I calculate the perimeter of this triangle, I know that that's going to be all three sides added up, which is going to give me 8 radical 3 plus 8 radical 3 plus radical 384. I want to take a look at the factors of 384 and see if any of them happen to be perfect squares. That's not a number I know off the top of my head, so on my calculator I can go into this and into y equals type in 384 divided by x. Take a look at my table, and when I look at my table, I can see right in here that I end up having 64 as a factor of 384. So when I split that up, I know that that's going to be the largest perfect square factor. So this is 8 radical 3 plus 8 radical 3 plus radical 64 radical 6. So 16 radical 3 plus 8 radical 6 becomes my final answer on that, because I cannot combine these two terms together because they are unlike radicals. So that is the final answer. To calculate the area, we know that it's a triangle, 1/2 base times height. In this case, we've already talked about how the base and the height are the two sides that meet at the right angle. So I know that I have a base of 8 radical 3 and a height of 8 radical 3. Final answer then, when I go through to calculate this, I multiply these two radicals together. 64 radical 3 times radical 3, when I multiply them, gives me radical 9, which is just 3. So half of 64 is 32. 32 times 3 gives me 96. So final answer for the area, 96. If I turn the page, in question number 2, same idea, simplest form of the perimeter and area of a rectangle whose length is 5 radical 4 and whose width is radical 75. I find it helpful in these circumstances to actually draw the rectangle. It gives me a good visual of what's going on. The length is 5 radical 45 and the width is 75. I think in this case it might be a little bit easier to actually simplify those sides first. So when I take a look at radical 75, I know that I'm going to use 25 and 3, which gives me 5 radical 3. If I take a look at the length, 5 radical 9 radical 5. So this will give me 15 radical 5. So I'm going to end up using, in this particular case, I'm going to end up using this as the width and this is the length. So when I go through now and I calculate the perimeter, I know that perimeter means add up all 4 sides, and I have 2 sides of 5 radical 3, and I have 2 sides of 15 radical 5. So this will end up giving me 10 radical 3 plus 30 radical 5. And that is going to be my final answer for the perimeter. When I go back and do area, we know the area of a rectangle is length times width. So this will be 5 radical 3 times 15 radical 5. When I multiply those two together, I end up with 75 radical 15. And that is my final answer also. There's nothing I can do to go through and simplify that. I'm going to skip number 3 for right now. I may come back to it in another video. And I'm going to go ahead and take a look at question number 4. I'm picking to talk about question number 4 because it is a trapezoid. I want to make sure that you remember how to do the formula for the area of a trapezoid. So I'm going to go in and look at this. Here's my trapezoid. Does not tell me it's isosceles, so I'm not going to draw mine and mark it as being isosceles. It says it has bases of 2 radical 60 and radical 135. It also tells me that in this I have a height of 7 radical 2. So I'm going to draw that height in. Remember, the height hits both of the bases at a right angle. So when I go through now to calculate the area of this, area equals 1/2 the height, base 1 plus base 2. Some of you may write that formula a little bit differently. Some of you may write it as height, base 1 plus base 2, divided by 2, and that's fine as well. Whatever works for you is fine. I'm going to plug in my information, but before I actually go through and do that, when I take a look back at the bases, I see that those bases can be simplified, so I think I'm going to do that first before I actually plug them in. So radical 60, I know I can split that up into 4 and 15, which will give me 2 times 2, which is 4 radical 15. And then 135, maybe that's another one that you don't know the factors of. Just as a little reminder, you can go to your calculator and type in that you want to do 135 divided by x. Take a look at your table, and when you take a look at your table, maybe in the first section that you see on your table over here, you may not see any factors, but if you arrow down in your table, so let's go ahead and take a look at the table. Hang on, maybe I hit the wrong button. There we go. And I arrow down, I can see that one of my factors that goes into 135 is the 9 over here. So 9 is a perfect square factor. So I'm going to go in now and say, okay, radical 35, radical 9, radical 15, which gives me 3 radical 15. That's extremely convenient because now both of these two are radical 15 terms. So when I substitute them in over here, I will be able to combine them together. So my area will be, I'm going to multiply these two together, and I'm going to combine these. So when I multiply those, I get 7 over 2 radical 2, and then inside the parentheses, I have 7 radical 15. So my final answer in this case, when I multiply 49 over 2, multiply fractions, make sure that they, the 7 over 1 that has a denominator, multiply the tops together, multiply the bottoms together, and then radical 30. So final answer, 49 over 2, radical 30. Question number 5 we will do together also. It's talking about a rhombus. Remember, a rhombus is a square that's kind of tilted on its side. So here's my rhombus. It is talking about the diagonals, so I've drawn them in. One of the things that we talked about previously with respect to a rhombus is that the diagonals do bisect each other. So each of the two parts will be congruent, and also that the diagonals are perpendicular. That's extremely important in a problem like this because that means that whatever of the 4 triangles it is that we're talking about, it is going to be a right triangle. So if one of my side lengths, diagonal lengths, let's say this one, is 2 radical 10, then that means half of it is 1 radical 10. And then the other one that we have here, the other diagonal, 12 radical 6, so half of it is going to be 6 radical 6. If I'm looking for the perimeter of this rhombus, it means that I have to add up all 4 equal sides. And when I add up those 4 equal sides, that will give me what the perimeter is. The problem is I don't know how big one of those equal sides are, but if I take this triangle that's right here, I can do Pythagorean theorem on it to find the missing side of the rhombus. It's the side of the triangle, but it's also the side of the rhombus. So in this case, I have radical 10 squared plus 6 radical 6 squared. So I end up with radical 10 squared. Remember, the square root and the square cancel each other out, so just 10. And then 36 times 6. So this gives me 10 plus 216 equals c squared. So c is equal to, if I go through and square root, well, I'll do this. C squared is equal to 226. And then if I square root now, remember when we square root, we get two answers, so it's plus or minus 226, but we know that we're not going to use the minus because it's a side length. I don't know the factors of 226 off the top of my head, so again, I'm going into my calculator and typing in 226 divided by x, enter. I'm going to take a look at my table. When I look at my table, I can see initially, based on what I see in my table up here, that I don't see any perfect square factors. I'll kind of scan through here, go up a little bit. I'm going to check 9. I'm going to check 4. I don't see any. Keep checking. 16. 25, no. 36, no. So it appears that there are no perfect square factors of 226. So in this case, my final answer will be just the square root of 226. Not final answer. This is final answer for the side of the rhombus, but we still need to go back now and do the perimeter. When I do the perimeter, all four sides are the same, so I can do 4 times that one side length of radical 226. So perimeter will be 4 radical 226. I have left question number 6. We're not going to do that one together right now. And I'm going to allow you to go ahead and work on question 3 on your own and question 6 on your own. And I'm going to do an additional video where I put that information up here and you can check your work.